Obergefreiter Klaus Weber pressed his field glasses against the concrete lip of the bunker, scanning the rolling French countryside that stretched endlessly toward the American lines. The autumn sun cast long shadows across the farmland, creating a deceptive peace over terrain that had become a killing field. For 6 weeks, his artillery unit had dominated this sector with mathematical precision, their 88mm guns reaching targets at ranges the Americans could not match. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. What Weber could not possibly know as he adjusted his binoculars and prepared for another routine counter-battery mission was that 23 kilometers away, American artillerymen were loading a shell into a weapon that would shatter every assumption German forces held about the limitations of enemy firepower. In exactly 14 minutes, he would become among the first German soldiers to witness the devastating reach of America's 240mm Howitzer, a weapon capable of delivering destruction from distances that defied everything the Wehrmacht understood about artillery warfare. The massive American gun, nicknamed Black Dragon by its crew, possessed capabilities that would fundamentally alter the psychological landscape of the European theater. Its 35-mile range transformed defensive positions that German commanders believed to be safely beyond enemy artillery into vulnerable targets subject to annihilation without warning. The mathematical certainty that had sustained German tactical planning was about to be replaced by the terrifying uncertainty of facing weapons that could strike from distances previously considered impossible. Weber's story represents more than a single soldier's encounter with superior American technology. It illuminates the moment when German military confidence, built upon years of technological superiority and tactical excellence, confronted the industrial might of American democracy, focused toward a single purpose: the complete defeat of fascism through overwhelming firepower applied at unprecedented ranges. The transformation of warfare through long-range precision artillery would prove as psychologically devastating as it was tactically effective. German forces, accustomed to calculating safe distances and establishing defensive positions based on known enemy capabilities, suddenly found themselves vulnerable to destruction that could arrive without warning from directions they could not observe or counterattack. This is the story of how American industrial innovation, combined with mathematical precision and operational excellence, created weapons that extended the reach of democratic values far beyond the physical battlefield. The 240mm Howitzer did not merely destroy German positions. It destroyed German certainty, German confidence, and German faith in their ability to predict and control the tactical environment that determined survival or death. The thunder that Weber was about to hear would echo not only across the French countryside, but through the corridors of German high command, where planners would be forced to recalculate every assumption about defensive positioning, artillery protection, and the mathematical relationships that governed modern warfare. The sound of that distant explosion would mark the beginning of the end for German artillery dominance on the Western Front. Weber's artillery unit, the 2nd Battery of Artillery Regiment 256, had established their reputation through methodical excellence in counter-battery operations. Their 88mm guns, positioned in carefully surveyed emplacements along the Moselle River Valley, provided overlapping fields of fire that could engage American artillery at maximum effective ranges, while remaining protected by terrain and distance. The German doctrine emphasized mathematical precision in artillery employment. Every battery position was selected after extensive terrain analysis, calculated to provide optimal fields of fire while maintaining protection from counter-battery fire. Range cards were prepared with meticulous attention to detail, identifying potential target areas, with mathematical accuracy that reflected German engineering excellence applied to the science of destruction. Weber had participated in 37 successful counter-battery missions since arriving in the Met sector in July. The pattern was always the same. American artillery would begin firing from positions their forward observers believed to be beyond German retaliation range. German sound-ranging equipment would locate the enemy batteries through acoustic analysis. Within minutes, precisely calculated fire missions would silence the American guns, often before they could displace to alternate positions. This mathematical certainty had created psychological confidence that sustained German morale, despite the obvious material disadvantages they faced in the autumn of 1944. While American forces possessed overwhelming advantages in personnel, equipment, and logistical support, German artillery crews maintained tactical superiority through precision, professionalism, and thorough understanding of ballistic mathematics applied to real-world conditions. The 88mm guns employed by Weber's unit represented the pinnacle of German artillery design. Originally developed as anti-aircraft weapons, these guns had been adapted for ground combat roles, where their high velocity and flat trajectory provided exceptional accuracy at extended ranges. The crews had trained for months to achieve loading speeds that approached the theoretical maximum, enabling rapid engagement of multiple targets before enemy forces could implement effective counter-battery procedures. Each gun crew consisted of 7 highly trained specialists, whose coordinated efforts enabled sustained rates of accurate fire that maximized both psychological and physical impact on enemy forces. The gunner, assisted by advanced optical equipment, could achieve first-round hits at ranges exceeding 12 kilometers under optimal conditions. The loader and ammunition handlers maintained firing rates that sustained psychological pressure on enemy positions, while conserving ammunition through precision rather than volume. Weber's role as forward observer required intimate knowledge of terrain, ballistics, and communication procedures that enabled real-time coordination between observation posts and firing batteries. His training had emphasized the mathematical relationships between range, elevation, weather conditions, and target characteristics that determined the difference between effective fire missions and wasted ammunition. The observation post on Hill 394 provided commanding views of the Seis River Valley, where American forces had established artillery positions in support of their advance toward Metz. German intelligence had identified 17 separate American battery positions within their sector, all located at ranges that placed them within effective engagement distance of German counter-battery fire. This tactical situation had created a deadly chess game where American artillery would attempt to provide fire support for advancing infantry, while German batteries worked systematically to locate and destroy enemy guns before they could achieve tactical objectives. The mathematical precision required for success in this environment demanded exceptional professional competence from artillery crews on both sides. Weber's unit had achieved consistent success in this counter-battery duel through superior training, better equipment, and tactical procedures that maximized their advantages while minimizing exposure to enemy retaliation. Their position on the high ground east of Metz provided observation capabilities that enabled rapid target acquisition and accurate fire direction, while their camouflaged positions offered protection from aerial observation and counter-battery fire. The Germans had established a defensive system that utilized terrain advantages, mathematical precision, and professional excellence to offset American material superiority. Every aspect of their operation was calculated to maintain tactical dominance through superior application of artillery science, even when facing enemy forces that possessed overwhelming advantages in numbers and logistical support. The afternoon of September 14th had proceeded according to patterns that had become routine over the previous 6 weeks. American artillery had conducted harassing fire missions against German positions along the Moselle River, carefully avoiding counter-battery engagements that might expose their gun positions to German retaliation. The enemy fire was accurate enough to disrupt German operations, but not sustained enough to indicate major offensive preparations. Weber had observed 3 separate American fire missions during the morning hours, each lasting approximately 15 minutes and consisting of harassment rather than systematic destruction fire. The pattern suggested that American commanders were conducting reconnaissance by fire, attempting to identify German defensive positions without committing to sustained artillery duels that might result in the loss of their own batteries. German sound-ranging equipment had successfully located 2 of the American firing positions, but the targets were positioned at maximum range for effective counter-battery fire. German commanders had chosen to monitor these positions rather than engage them immediately, preferring to maintain operational security while gathering intelligence about American artillery capabilities and tactical procedures. This tactical restraint reflected German understanding that successful artillery operations required patience, precision, and careful husbanding of ammunition resources that were increasingly difficult to replace. Every shell fired needed to achieve tactical results that justified the expenditure, particularly when enemy material advantages made sustained artillery duels increasingly problematic for German forces. The observation post maintained constant communication with battery fire direction centers through telephone lines that had been carefully concealed and protected against enemy interdiction. This communication network enabled rapid coordination between forward observers and firing batteries, allowing German artillery to respond to targets of opportunity with minimal delay while maintaining operational security. Weber's primary responsibility involved monitoring American artillery activities and providing early warning of fire missions that might threaten German positions. His training enabled him to distinguish between different types of enemy artillery based on sound signatures, muzzle velocities, and projectile characteristics that could be observed through careful attention to ballistic trajectories and impact patterns. The equipment available to Weber included high-quality German optical instruments that provided exceptional clarity and magnification for target observation at extended ranges. His binoculars, manufactured by Zeiss according to specifications developed for military applications, enabled detailed observation of enemy activities at distances that exceeded the effective range of most small arms fire. Communication procedures required Weber to maintain contact with his battery fire direction center every 15 minutes, reporting observations and receiving updates about friendly artillery activities that might affect his sector of responsibility. These procedures ensured coordinated response to enemy activities, while preventing friendly fire incidents that could result from miscommunication or inadequate coordination. The tactical situation had achieved a temporary equilibrium, where both sides conducted limited operations designed to gather intelligence and maintain pressure without triggering major engagements that might expose positions to enemy retaliation. This equilibrium reflected the mathematical precision that both sides applied to artillery operations, where every action was calculated to achieve specific objectives while minimizing risks. German artillery doctrine emphasized the importance of maintaining initiative through superior professionalism and mathematical precision, even when facing enemy forces that possessed material advantages. This doctrine had proven successful in previous engagements, enabling German forces to achieve tactical objectives through superior application of artillery science, rather than overwhelming firepower. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. At exactly 2:31 p.m., Weber observed a phenomenon that challenged everything he understood about artillery warfare. The distinctive crack of an incoming projectile reached his position simultaneously, with an explosion that erupted from German positions located more than 20 kilometers behind his observation post, far beyond the range of any American artillery weapon he had previously encountered. The sound signature was unlike anything in his experience. Instead of the familiar whistle of 105mm, or 155mm American projectiles, this sound resembled a freight train traveling at tremendous velocity through the atmosphere above his position. The projectile passed overhead at an altitude that indicated a trajectory calculated for extreme range, rather than the flatter trajectories associated with direct fire missions. Weber immediately reached for his field telephone to report the unusual artillery activity, but before he could establish communication with his battery fire direction center, a second projectile followed the same trajectory. This time he was able to observe the impact through his binoculars, witnessing an explosion of such magnitude that it created a mushroom cloud visible from his position 23 kilometers away. The explosion completely destroyed a German ammunition depot that had been considered immune to American artillery due to its location well behind the forward edge of battle area. The facility had been positioned according to mathematical calculations that placed it beyond the maximum range of known American artillery weapons, with additional safety margins that should have provided absolute protection from enemy fire. The destruction was so complete and sudden that Weber initially assumed he was witnessing the results of aerial bombardment rather than artillery fire. The size of the explosion, combined with the apparent ease with which the American gunners had located and destroyed a carefully concealed target, suggested capabilities that exceeded anything German intelligence had identified regarding enemy artillery systems. Weber's training enabled him to calculate approximate range and bearing to the target area, confirming that the destruction had occurred at distances that should have been impossible for American artillery weapons. The mathematical impossibility of what he was observing created cognitive dissonance that challenged his understanding of artillery capabilities and tactical planning. Within minutes, additional projectiles began falling on German positions throughout the sector, each impact occurring at ranges that defied known limitations of American artillery systems. The pattern of impact suggested systematic engagement of targets that German commanders had considered completely protected from enemy artillery fire due to distance and terrain masking. The psychological impact was immediate and devastating. German forces had organized their defensive positions based on mathematical certainty regarding enemy artillery capabilities. Positions located beyond known American artillery ranges were considered safe areas where personnel could rest, equipment could be maintained, and supplies could be stored without concern for enemy interdiction. The sudden vulnerability of previously safe areas created panic that spread rapidly through German communication networks. Units that had operated with confidence based on mathematical precision now found themselves exposed to destruction from weapons they could not observe, locate, or engage with counter-battery fire due to the extreme ranges involved. Weber attempted to report his observations to higher headquarters, but discovered that communication lines to rear areas had been severed by the same long-range artillery fire that had destroyed the ammunition depot. The American gunners were demonstrating systematic capability to engage targets throughout the German defensive system simultaneously, creating disruption that prevented coordinated response to the unexpected threat. The realization that American forces possessed artillery capabilities that exceeded German estimates by such enormous margins created immediate tactical implications that extended far beyond the physical destruction being inflicted. Every aspect of German defensive planning would require complete revision to account for enemy weapons that could deliver precision fire at ranges previously considered impossible. The weapon creating such devastating psychological impact on German forces was the American 240mm Howitzer M1, a piece of artillery that represented the pinnacle of American industrial engineering applied to the science of long-range precision fire. The massive gun weighed over 64,000 pounds in firing position and required specialized transportation equipment that reflected American logistical capabilities unique among combatant nations. The 240mm projectile weighed 360 pounds and contained explosive charges that produced blast effects equivalent to aerial bombs, enabling single rounds to destroy targets that would require multiple hits from conventional artillery weapons. The combination of projectile weight, explosive content, and precision accuracy created capabilities that fundamentally altered tactical calculations regarding target vulnerability and defensive positioning. American engineers had solved technical challenges that German artillery designers had considered impossible to overcome within practical limitations of mobile artillery systems. The gun's maximum range of 35 miles exceeded German estimates of American artillery capabilities by more than 200%, creating tactical surprise that enhanced the weapon's physical effectiveness through psychological impact on enemy forces. The precision accuracy achieved by American 240mm batteries reflected integration of advanced fire control systems, mathematical calculation procedures, and communication technologies that enabled first-round hits on targets at maximum range under combat conditions. This combination of range and accuracy created capabilities that approached strategic weapon effectiveness while maintaining tactical mobility and operational flexibility. German technical intelligence had failed completely to detect American development of 240mm artillery systems, despite normally excellent intelligence networks that provided detailed information about enemy equipment and capabilities. The security surrounding American long-range artillery development had prevented German forces from implementing countermeasures or tactical adjustments that might have reduced the weapon's effectiveness. The industrial requirements for producing 240mm ammunition represented American manufacturing capabilities that German planners had considered impossible to achieve while maintaining production of conventional ammunition types. Each projectile required precision machining, specialized steel alloys, and explosive components that demanded industrial resources unavailable to German forces. American artillery doctrine emphasized the integration of long-range precision fire with tactical mobility that enabled rapid displacement after fire missions, preventing effective German counter-battery operations. The 240mm howitzers could engage targets at ranges that placed them beyond German counter-battery capabilities, while maintaining accuracy that eliminated the need for sustained fire missions that might reveal their positions. The mathematical precision required for effective employment of 240mm howitzers demanded training standards that exceeded anything available to German artillery crews operating under wartime conditions. with limited resources for specialized instruction. American gunners had received months of intensive training in ballistic calculations, meteorological corrections, and precision survey techniques that enabled maximum effectiveness from their advanced weapons. The logistical requirements for supporting 240mm artillery operations reflected American industrial and transportation capabilities that German forces could not match or counteract effectively. Each gun required specialized ammunition, maintenance support and transportation equipment that demonstrated American commitment to providing their forces with technological superiority, rather than accepting tactical parity with enemy forces. German recognition of American 240mm capabilities created immediate requirements for defensive adjustments that German forces lacked resources to implement effectively. Protection against 35-mile artillery fire required dispersal patterns and underground fortification that exceeded available engineering resources while maintaining operational effectiveness of defensive systems. Weber's personal experience of witnessing impossible artillery fire represented the individual psychological impact of confronting weapons that challenged fundamental assumptions about warfare and survival. The mathematical certainty that had provided psychological foundation for German tactical planning was replaced by uncertainty that affected decision-making at every level of military operations. The destruction of the ammunition depot had killed 17 German soldiers, who believed themselves to be positioned safely beyond enemy artillery range. Their deaths represented the human cost of intelligence failures that prevented German forces from implementing protective measures against weapons they did not know existed until they experienced their effects directly. Survivors of the initial 240mm artillery strikes reported psychological effects that extended far beyond physical casualties inflicted by the bombardment. The sudden vulnerability of previously safe areas created anxiety that affected performance of routine duties and confidence in command decisions regarding positioning and tactical planning. German medical personnel observed increased rates of combat exhaustion among soldiers exposed to long-range American artillery fire, even when physical casualties were minimal. The psychological pressure of facing weapons that could deliver destruction from invisible, unreachable positions created stress reactions that reduced combat effectiveness throughout affected units. Command relationships were strained by the inability of German officers to provide accurate information about enemy capabilities or effective protection for their subordinates. Traditional military leadership relied upon competence in tactical planning and risk assessment that became impossible when enemy capabilities exceeded known parameters by such enormous margins. Communication between forward positions and rear headquarters became increasingly difficult as German forces implemented dispersion measures designed to reduce vulnerability to long-range artillery fire. These measures, while necessary for survival, degraded coordination and command effectiveness that German units required to maintain tactical competence against superior enemy forces. The impact on German morale extended beyond units directly exposed to 240mm artillery fire, as reports of American long-range capabilities spread through communication networks and created concern about the adequacy of existing defensive preparations throughout the Western Front. Units that had never experienced direct fire from American long-range artillery began implementing protective measures that reduced their operational effectiveness. German soldiers began questioning the accuracy of intelligence information provided by higher headquarters, recognizing that command estimates of enemy capabilities had proven dangerously inadequate. This erosion of confidence in official information affected willingness to accept tactical guidance and reduced effectiveness of command decisions that required subordinate cooperation for successful implementation. Personal survival strategies adopted by individual German soldiers reflected recognition that official protective measures were inadequate against American long-range artillery capabilities. Soldiers began making individual decisions about positioning and movement that prioritized personal survival over unit tactical objectives, degrading overall military effectiveness. The realization that American industrial capabilities had produced weapons that exceeded German technical achievements by such substantial margins created broader psychological impact regarding the ultimate outcome of the war. German recognition of American technological superiority in artillery translated to concerns about overall technological competition that affected confidence in ultimate German victory. Weber's experience of witnessing destruction delivered from distances he considered impossible represented the individual human moment when mathematical certainty was replaced by tactical uncertainty that would characterize German operations for the remainder of the war. The sound of that first 240mm projectile passing overhead marked the end of German confidence in their ability to predict and control the battlefield environment through superior professional competence and mathematical precision. Major General William Harrison stood before the massive forging press that would shape the steel destined to become America's most powerful artillery weapon. The industrial cathedral surrounding him hummed with the systematic precision of American engineering focused toward a single purpose: creating weapons that would extend democratic firepower beyond any range previously achieved in military history. The 240mm Howitzer project represented more than advanced artillery development. It embodied the fundamental American approach to warfare that prioritized overwhelming technological superiority over mere numerical advantage. Where other nations accepted limitations imposed by existing technology, American engineers systematically eliminated those limitations through industrial innovation that transformed theoretical possibilities into practical battlefield realities. General Harrison had witnessed the mathematical precision of German artillery during his service as military observer in North Africa, where Wehrmacht units demonstrated tactical excellence that overcame material disadvantages through superior professional competence. The experience taught him that American victory would require weapons that eliminated German tactical advantages through capabilities so overwhelming that professional competence became irrelevant against absolute technological dominance. The steel being forged under his observation would become gun barrels capable of delivering 360-pound projectiles across distances that challenged fundamental assumptions about artillery warfare. The metallurgical precision required for manufacturing these weapons demanded industrial capabilities that existed nowhere else in the world, reflecting American commitment to achieving battlefield superiority through engineering excellence rather than accepting tactical parity. The Watervliet arsenal represented American industrial democracy applied to weapons manufacturing. The facility employed 18,000 skilled workers whose expertise spanned metallurgy, precision machining, ballistics engineering, and quality control procedures that ensured every weapon produced would meet performance specifications that exceeded theoretical requirements. The systematic approach to weapons production reflected American understanding that democratic victory required industrial systems that could not be matched or replicated by totalitarian opponents. Harrison observed workers whose fathers had built the machines that won the previous war, now applying inherited expertise to weapons that would define the outcome of the current conflict. The continuity of American industrial capability created competitive advantages that transcended individual battles or campaigns, establishing long-term superiority through systematic application of engineering knowledge accumulated across generations of technological development. The mathematical challenges involved in creating 35-mile artillery range required solving ballistic equations that had been considered impossible under practical manufacturing constraints. American engineers approached these challenges through systematic methodology that eliminated limitations through precision rather than accepting compromise solutions that other nations had adopted when confronting similar technical difficulties. The forging process required steel quality that exceeded specifications for naval gun construction, demanding metallurgical precision that reflected American commitment to achieving theoretical maximum performance from every weapon system. The industrial infrastructure necessary for producing such weapons represented investment in technological superiority that would provide competitive advantages extending far beyond the immediate military conflict. General Harrison understood that the 240mm Howitzer would accomplish strategic objectives through psychological impact that amplified its tactical effectiveness. German forces had organized their defensive planning around mathematical certainty regarding American artillery capabilities. Weapons that exceeded those calculations by enormous margins would create tactical uncertainty that affected German decision-making at every level of military operations. The project timeline demanded completion within 14 months, requiring coordination between multiple industrial facilities that would need to achieve unprecedented precision in components that had never been manufactured at such scale. The logistical complexity of orchestrating simultaneous production at facilities across 12 states reflected American organizational capabilities that no other nation possessed during wartime conditions. American artillery doctrine emphasized integration of superior firepower with tactical mobility that enabled rapid displacement after engagement, preventing effective enemy counter-battery operations. The 240mm Howitzer would extend this doctrine to ranges that placed American artillery completely beyond German retaliation, while maintaining accuracy that eliminated the need for sustained bombardments that might reveal firing positions. The psychological impact on American forces would prove as significant as the effect on enemy troops. Knowledge that their artillery possessed capabilities that exceeded enemy weapons by such substantial margins would provide confidence that sustained morale through difficult operations. American infantry advancing under protection of 35-mile artillery support would operate with tactical assurance unavailable to any previous military force. Harrison recognized that successful completion of the 240mm project would establish technological precedents that would influence military engineering long after the current conflict concluded. The industrial methods developed for producing ultra-long-range artillery would provide foundation for post-war technological development that would maintain American military superiority through continuing innovation rather than temporary advantage. The workforce assembled for the 240mm project included engineers who had left private industry to contribute their expertise to national defense, reflecting American commitment to mobilizing the entire industrial base toward achieving military objectives. The voluntary nature of this mobilization created productivity advantages that conscripted labor could not match, demonstrating democratic superiority through willing participation rather than coercive organization. Quality control procedures developed for the 240mm project established standards that would revolutionize American weapons manufacturing, creating systematic approaches to precision production that eliminated variability in weapon performance. Every gun barrel would deliver identical ballistic performance, ensuring that tactical planning could rely upon mathematical certainty regarding weapon capabilities. The ammunition production requirements for supporting 240mm operations demanded development of entirely new manufacturing processes that could produce precision projectiles at scale sufficient to sustain combat operations. Each shell required machining tolerances that approached scientific instrument precision, reflecting American commitment to achieving maximum effectiveness through quality rather than accepting reduced performance in exchange for easier production. General Harrison observed the systematic approach to complex manufacturing that characterized American industrial capability. Problems that might have required months to solve in other nations were resolved through collaborative engineering that applied multiple expertise areas simultaneously, creating solutions that incorporated the best available knowledge rather than compromising between competing approaches. The testing procedures for validating 240mm performance would require establishing firing ranges that exceeded existing American facilities, demanding construction of specialized proving grounds where weapon capabilities could be evaluated under conditions that simulated combat requirements. The investment in testing infrastructure reflected understanding that weapon effectiveness depended upon thorough validation of performance claims through actual firing rather than theoretical calculation alone. Transportation requirements for moving 240mm howitzers to combat theaters would necessitate development of specialized equipment that could handle weapons weighing over 64,000 pounds while maintaining mobility necessary for tactical employment. The logistical challenges involved in supporting ultra-heavy artillery operations would test American organizational capabilities in ways that no previous weapon system had required. The industrial coordination necessary for successful completion of the 240mm project demonstrated American ability to organize complex manufacturing operations that achieved unprecedented technical objectives through systematic application of engineering expertise. The project management techniques developed for coordinating multiple facilities toward common goals would establish methods that would influence American industrial organization for decades following the war. Harrison understood that the 240mm howitzer represented more than advanced weapons technology. It embodied American industrial democracy, applied to the systematic elimination of enemy advantages through overwhelming technological superiority. The weapon would demonstrate that democratic societies could produce military capabilities that exceeded anything achievable through totalitarian organization, proving that freedom enhanced rather than limited industrial effectiveness. The mathematical precision required for achieving 35-mile artillery accuracy demanded ballistic calculations that exceeded the computational capabilities available to German forces, creating tactical advantages that reflected American investment in advanced mathematical methods applied to military problems. The systematic approach to ballistic science would establish American superiority in precision weapons that would continue long after the current conflict concluded. The metallurgical innovations necessary for producing 240mm gun barrels would advance American steel technology in ways that would benefit industrial development across multiple sectors, demonstrating how military requirements could drive technological progress that provided broad economic advantages. The knowledge gained through solving ultra-high-pressure metallurgical challenges would contribute to post-war industrial capabilities that maintained American technological leadership. American commitment to achieving theoretical maximum weapon performance through precision manufacturing established industrial standards that would influence global military technology development, creating precedents that would maintain American competitive advantages through systematic excellence rather than temporary innovations. The 240mm project represented systematic investment in long-term technological superiority that would transcend individual conflicts. The workforce expertise assembled for the 240mm project included specialists whose knowledge would contribute to American technological development across multiple fields, creating human resource advantages that would continue benefiting national capabilities long after military requirements concluded. The systematic approach to mobilizing technical expertise demonstrated democratic efficiency in organizing intellectual resources toward common objectives. General Harrison observed that the 240mm Howitzer would accomplish strategic objectives that extended far beyond its immediate military application. The weapon would demonstrate American industrial capability to allies and enemies alike, establishing credibility that would influence diplomatic relationships and strategic planning throughout the remainder of the conflict and into the post-war period. The systematic approach to achieving impossible technical objectives through coordinated engineering effort would establish American reputation for solving complex problems that other nations considered impractical, creating international recognition of American technological capabilities that would provide strategic advantages in future conflicts and diplomatic negotiations. The industrial infrastructure developed for producing 240mm weapons would remain available for future military requirements, creating permanent capabilities that would enable rapid development of advanced weapon systems in response to changing strategic requirements. The investment in ultra-precision manufacturing would provide foundation for maintaining technological superiority through continuing innovation, rather than depending upon temporary advantages. Harrison recognized that the 240mm project represented the systematic application of American industrial democracy toward achieving military objectives that would ensure democratic victory through overwhelming technological superiority. The weapon would demonstrate that free societies could organize industrial capabilities that exceeded anything achievable through totalitarian methods, proving the superiority of democratic organization through practical results rather than theoretical arguments. The completion of the 240mm Howitzer would mark the moment when American artillery achieved technological dominance that eliminated enemy advantages through mathematical certainty rather than tactical maneuvering. The weapon would transform battlefield mathematics from complex calculations regarding relative capabilities to simple recognition that American firepower could reach any target within the theater of operations with precision that guaranteed destruction. The systematic approach to engineering excellence that characterized the 240mm project would establish methods and standards that would influence American military technology development for decades, creating institutional capabilities that would maintain technological superiority through continuing innovation rather than depending upon individual breakthroughs or temporary advantages over potential opponents. Captain Robert Eisenhower stood in the pre-dawn darkness beside the massive 240mm Howitzer that would soon validate months of theoretical ballistic calculations through actual fire. The weapon represented the culmination of American engineering excellence applied to the systematic destruction of enemy positions at ranges previously considered impossible for mobile artillery systems. The mathematical challenges involved in achieving accurate fire at 35 miles demanded solving ballistic equations that incorporated meteorological variables, Earth curvature effects, projectile characteristics, and precision manufacturing tolerances that exceeded anything previously attempted in artillery development. The systematic approach to overcoming these challenges demonstrated American commitment to achieving theoretical maximum performance through scientific methodology, rather than accepting practical limitations. Captain Eisenhower possessed the mathematical education necessary for understanding the complex relationships between muzzle velocity, projectile weight, atmospheric conditions, and target coordinates that determine successful employment of ultra-long-range artillery. His background in ballistics engineering reflected American investment in professional military education that prepared officers to maximize effectiveness of advanced weapon systems through scientific understanding rather than intuitive judgment. The Proving Ground testing program would validate performance claims through systematic firing that demonstrated actual capabilities under controlled conditions before committing the weapon to combat employment. The methodical approach to proving weapon effectiveness reflected American understanding that battlefield success required thorough validation of theoretical performance through practical demonstration under realistic conditions. The 240mm projectile weighed 360 pounds and contained explosive charges that produced blast effects equivalent to aerial bombardment, enabling single rounds to destroy targets that would require multiple hits from conventional artillery weapons. The combination of projectile mass, explosive content, and precision accuracy created capabilities that fundamentally altered tactical calculations regarding target vulnerability and defensive positioning. American ballistics engineers had solved technical challenges that European artillery designers had considered impossible to overcome within practical constraints of mobile weapons systems. The mathematical precision required for achieving consistent accuracy at maximum range demanded computational capabilities that exceeded anything available to German forces, creating tactical advantages that reflected systematic investment in advanced scientific methods applied to military problems. The testing protocol established for validating 240mm performance-incorporated variables that simulated combat conditions more accurately than any previous artillery evaluation program. Meteorological stations positioned throughout the firing range provided real-time atmospheric data that enabled ballistic calculations incorporating wind speed, air density, temperature variations, and humidity levels that affected projectile flight characteristics at extreme ranges. Captain Eisenhower observed the systematic coordination between multiple technical specialties that enabled successful employment of ultra-long-range artillery. Survey teams had established precise target coordinates using advanced triangulation methods that provided accuracy sufficient for achieving first-round hits at maximum range. The mathematical precision required for effective fire direction exceeded capabilities available to any other military force operating during the current conflict. The fire control procedures developed for 240mm operations integrated advanced communication systems, ballistic calculation methods, and precision survey techniques that enabled rapid engagement of targets, while maintaining accuracy standards that guaranteed destruction with minimum ammunition expenditure. The systematic approach to fire direction demonstrated American understanding that advanced weapons required correspondingly advanced employment procedures to achieve maximum effectiveness. Quality control standards established for 240mm ammunition production ensured that every projectile delivered identical ballistic performance, eliminating variability in weapon effectiveness that might compromise tactical planning. The precision manufacturing requirements for producing consistent ammunition reflected American industrial capabilities that enabled reliable performance from advanced weapon systems under combat conditions. The mathematical models developed for predicting 240mm trajectory behavior incorporated atmospheric physics, projectile aerodynamics, and Earth curvature effects that had been considered too complex for practical artillery applications. American ballistics engineers approached these challenges through systematic methodology that eliminated theoretical limitations through scientific precision rather than accepting compromise solutions. The Proving Ground facilities constructed for testing ultra-long-range artillery represented investment in validation infrastructure that demonstrated American commitment to thorough evaluation of weapon capabilities before combat employment. The specialized instrumentation installed for measuring projectile performance at extreme ranges provided data collection capabilities that enabled continuous improvement of ballistic models through empirical observation. Captain Eisenhower recognized that successful validation of 240mm capabilities would establish technological precedents that would influence artillery development for decades following the current conflict. The scientific methods developed for achieving ultra-long-range accuracy would provide foundation for future weapon systems that would maintain American artillery's superiority through continuing innovation rather than temporary tactical advantages. The coordination required for conducting ultra-long-range firing tests involved multiple agencies that provided specialized capabilities necessary for comprehensive weapon evaluation. Meteorological services provided atmospheric data collection. Survey teams established precision target coordinates. Communication specialists maintained coordination between firing position and impact areas separated by distances that exceeded normal artillery observation capabilities. The ballistic calculations necessary for achieving first-round accuracy at 35 miles required mathematical precision that exceeded computational capabilities available to most military forces. American investment in advanced ballistic science created competitive advantages that reflected systematic application of scientific methodology to military problems rather than relying upon empirical experience alone. The instrumentation developed for measuring projectile performance during ultra-long-range flight provided data collection capabilities that enabled validation of theoretical ballistic models through actual observation. The scientific approach to weapon evaluation demonstrated American understanding that advanced capabilities required thorough validation through systematic testing, rather than accepting theoretical performance claims without practical verification. Captain Eisenhower understood that the 240mm Howitzer represented more than advanced artillery technology. The weapon embodied American systematic approach to eliminating enemy advantages through overwhelming technological superiority, achieved through scientific methodology, rather than tactical maneuvering. The mathematical precision required for effective employment would demonstrate American capability to solve complex technical problems that other nations considered impractical. The testing procedures established for 240mm evaluation incorporated safety protocols that protected personnel while enabling comprehensive weapon evaluation under realistic conditions. A systematic approach to managing ultra-long-range firing operations reflected American organizational capabilities that enabled safe conduct of complex technical operations that exceeded anything attempted by other military forces. The data collection systems established for monitoring 240mm performance provided information that would enable continuous improvement of weapon effectiveness through systematic analysis of actual firing results. The scientific approach to weapon development demonstrated American understanding that advanced capabilities required ongoing refinement through empirical observation rather than accepting initial performance levels as final standards. The precision manufacturing standards established for 240mm production ensured that weapon performance remained consistent across multiple units, enabling tactical planning based upon reliable capability estimates rather than variable performance characteristics. The systematic approach to quality control reflected American industrial capabilities that enabled mass production of advanced weapons without compromising individual unit effectiveness. Captain Eisenhower observed that the mathematical challenges involved in achieving ultra-long-range accuracy had driven development of computational methods that would benefit American scientific capabilities extending far beyond military applications. The ballistic calculation techniques developed for 240mm employment would contribute to advances in engineering mathematics that would enhance industrial capabilities throughout the post-war period. The systematic validation of 240mm capabilities through comprehensive testing demonstrated American commitment to achieving verified performance rather than accepting theoretical claims without practical confirmation. The methodical approach to weapon evaluation established standards that would influence military testing procedures for decades, creating institutional capabilities that would maintain technological advantages through continuing scientific advancement. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.